At first glance, it looks almost unreal, like a prop lifted from a science fiction film rather than a tool designed for the modern battlefield. Sharp angles, a compact frame, and a silhouette that seems to defy decades of conventional firearm design. But the moment the KRISS Vector enters the conversation, it becomes clear that this weapon is not trying to impress you with nostalgia or brute force. It is trying to challenge something far more fundamental: the limits of physics, control, and how humans interact with rapid fire. The KRISS Vector is not just a submachine gun. It is a question asked out loud by engineers who are tired of accepting recoil as an unavoidable truth. To understand why the KRISS Vector exists at all, you have to step back into the reality of close-quarters combat at the turn of the 21st century. Urban environments were becoming the dominant stage for conflict, law enforcement operations, and counter-terrorism missions. Tight corridors, crowded streets, and split-second decisions demanded weapons that were compact, controllable, and reliable under extreme stress. Traditional submachine guns had served this role for decades, but they carried a persistent problem. High rates of fire, combined with powerful cartridges, created recoil and muzzle climb that fought against the shooter, reducing accuracy when it mattered most. Engineers could refine ergonomics, add compensators, or adjust firing rates, but the core issue remained. Every shot pushed back, and that push added up. The KRISS Vector was born from a refusal to accept that limitation. Instead of asking how to manage recoil after it happened, its designers asked a far more radical question: what if recoil could be redirected before it disrupted control? This single idea would become the foundation of one of the most unconventional firearm designs of the modern era. The weapon's story begins not with a government contract or a military requirement, but with a private inventor, Renaud Kerbrot, and a company willing to gamble on an unorthodox vision. Kerbrot's concept revolved around a system that would later be known as the Super V mechanism. Rather than allowing the energy of firing to drive a bolt straight backward, as most firearms do, this system guided that energy downward. The moving mass followed a slanted path, channeling recoil toward the ground instead of directly into the shooter's shoulder. In theory, this would counteract muzzle rise and keep the weapon flatter during rapid fire. It was an elegant solution on paper, but transforming theory into a functioning firearm is where most radical ideas collapse. The early development of the KRISS Vector was marked by skepticism. Firearm design is a conservative field for good reason. Reliability is sacred, and radical departures from proven systems often introduce new failure points. Many experts doubted whether the Super V system could operate consistently under real-world conditions. Others questioned whether the benefits would justify the complexity. But as prototypes evolved into functional weapons, something remarkable became evident. The Vector behaved differently. It felt different. Observers noticed that during automatic fire, the muzzle did not climb in the familiar upward arc. Instead, it seemed anchored, almost unnaturally steady. This behavior was not magic, and it was not marketing illusion. It was physics, applied creatively. By redirecting recoil energy downward, the Vector reduced the rotational force that typically lifts a firearm's muzzle. The result was a shooting experience that challenged long-held assumptions about controllability. For law enforcement and military units accustomed to fighting recoil, the Vector offered a glimpse of an alternative future, one where accuracy during rapid fire was not a constant struggle. Yet the KRISS Vector did not emerge into a vacuum. Its introduction came at a time when the role of submachine guns was already under debate. Assault rifles with shorter barrels and intermediate cartridges were encroaching on territory once dominated by SMGs. Critics questioned whether a new submachine gun, no matter how innovative, could justify its place in an evolving arsenal. The Vector's designers understood this challenge, and they positioned the weapon not as a replacement for everything that came before, but as a specialized answer to specific needs. One of those needs was controllability with larger caliber pistol ammunition. The Vector was notably chambered for cartridges like .45 ACP, a round known for its stopping power but also for producing significant recoil. In traditional designs, firing such a cartridge at high rates could quickly become unwieldy. The Vector's recoil mitigation system made this combination more practical, allowing the weapon to harness the advantages of the cartridge without surrendering control. This choice reflected a broader design philosophy: embrace power, but refuse to be dominated by it. The psychological impact of such a weapon should not be underestimated. In high-stress environments, confidence in equipment can shape outcomes as much as raw capability. A firearm that feels stable, predictable, and controllable can reduce cognitive load on the operator. The KRISS Vector, with its distinctive recoil behavior, aimed to provide that sense of control. This was not about making combat easier or more glamorous, but about reducing chaos in moments where clarity could mean the difference between success and failure. As the Vector entered limited service and public awareness, it began to attract attention beyond its intended professional audience. Its futuristic appearance made it a favorite in popular media, video games, and films. This exposure amplified its reputation, sometimes blurring the line between reality and myth. The danger of such attention is that it can oversimplify complex tools, turning them into symbols divorced from their real-world context. The KRISS Vector became, for some, an icon of modern firepower rather than a carefully engineered response to specific tactical challenges. This is where responsible analysis becomes essential. The Vector did not revolutionize warfare overnight, nor did it render other weapons obsolete. Its adoption was measured, and in some cases cautious. Agencies and military units evaluated it alongside many other platforms, weighing factors like logistics, training, and long-term maintenance. Innovation alone is never enough. It must integrate into systems, doctrines, and human behavior. The Vector's story is as much about these constraints as it is about mechanical ingenuity. From a strategic perspective, the KRISS Vector represents a broader trend in weapon development: the shift from brute force toward refined control. Modern conflicts and security operations often unfold in environments where collateral damage carries enormous consequences. Precision, restraint, and accountability are no longer abstract ideals, but operational necessities. A weapon that can deliver controlled fire in confined spaces aligns with this reality, even as it raises ethical questions about the tools we create and the situations in which we deploy them. The geopolitical impact of the KRISS Vector is subtle but telling. Unlike mass-issued service rifles that define ERAs, the Vector occupies a niche. It reflects a world where specialized units face specialized threats and where technological solutions are tailored rather than universal. This fragmentation mirrors the complexity of modern security challenges. There is no single weapon that solves every problem, only tools designed to address specific slices of a much larger puzzle. At the same time, the Vector's existence challenges designers across the industry. It demonstrates that even in a field bound by tradition, there is room for reimagining fundamentals. Recoil, once treated as an unavoidable tax on firepower, became a variable to be manipulated. This mindset has implications beyond one weapon. It encourages engineers to question other assumptions, to look at long-accepted limitations and ask whether they are truly fixed or simply unchallenged. Of course, innovation comes with trade-offs. The KRISS Vector's unique system introduces complexity that demands careful manufacturing and maintenance. Its unconventional layout can require additional training for those accustomed to more traditional designs. These factors influence adoption decisions and remind us that no technological leap is free. Every gain is balanced by new demands, and understanding those demands is part of responsible evaluation. The cultural conversation around weapons often swings between extremes, from glorification to outright rejection. The KRISS Vector sits uneasily in this space, admired for its engineering while provoking discomfort about its purpose. This tension is not a flaw in the discussion, but a necessary part of it. Tools that can exert lethal force should never be stripped of their moral weight. Examining their design, impact, and context is one way of keeping that weight visible. In the end, the story of the KRISS Vector is not just about a submachine gun. It is about a moment when designers chose to confront a problem at its root, when physics became a canvas for creativity rather than a wall to lean against. It is about the balance between innovation and responsibility, and about how even small shifts in design philosophy can ripple outward, influencing how we think about control, power, and consequence. As you reflect on the KRISS Vector, consider what it represents beyond its striking appearance. It is a reminder that technology evolves not only through necessity, but through imagination, and that every new solution carries questions alongside answers. If you found this exploration meaningful, take a moment to share your thoughts in the comments, engage with others who are curious about the past and future of weapon design, and subscribe for more deep dives into the stories behind the machines that shape our world.